Great to be here. Thanks for the invitation. So before we start, let's have a few warm-up questions. So you probably saw the agenda that I'm going to talk about non-cellular 5G. How many of you have heard about that before today? That type of a term. Okay, good. And how many of you have heard about new acronym called DECT 2020 NR? About the same people. And the last question, how many of you have heard about Wirepas? Oh, Wirepas won 5G. That's great. Okay, so I hope you know a lot more of all those three after the discussion. So I will be talking about Wirepas shortly and where it's coming from, and Jari will be proud again where it is coming from. And then the concept of this decentralized mesh, but don't worry, I don't go into very deep technical details. I'm more on the concept level, and then a little bit about the standard itself, and probably about half of the time I will discuss about real life applications where this is used, because that gives a great flavor why a new standard is needed. And I hope that I'm short enough to leave time for Q&A. So let's get started, and we start with the video of Wirepas history.
Hi, my son Ville made the world's best 5G IoT, in my opinion. I'm not surprised. Ever since he was a little boy, he liked hard work. Really hard. They started the company in a garage here in Tampere. You see, here in Finland, we don't complain. We get the shit done. That's why we have more tech startups per capita than any other country in the world. And more Formula 1 champions, by the way. Ville's idea was to make something faster, smarter, better and cheaper. A very good idea, I think. I just hope he doesn't become lazy like his father.
Okay, so you know we explained the history to our brand office, and they came up with this, but it's not true really. The history is actually a spin-off from Tampere University of Technology, year 2010, and at the time, professors at the university were wondering that there will be a time when there's an endless amount of sensors around us, just endless amount. So how on earth those can be connected? And they came with a few challenges. First of all, how to manage the scale, and especially if you have a large scale in small location, the density becomes a problem as well. Then the second question was that how to solve the spectrum question. How there can be enough spectrum to connect all those millions of sensors. And the third one was that how to make it low power so that they can be battery operated. And that will then make the installation and deployment easier, but it also enable mobility. Great questions which are actually very, very valid still today, and that was about 20 years ago. Of course, since the technology and the products have been developed a lot further, so Wirepas was first focusing on hardware, actually, sensors and this protocol and gateways and back-end applications, and actually even sold as a service measurements to the real estate market in Finland. But then 2014, we made a turnaround in the company and made it to focus completely on software. And today we operate with partners around us, which are semiconductor partners, sensor makers, gateway makers, cloud and backend partners. We are today about 70 people, growing as we speak quite heavily. And we have probably almost 2,000 already developers in our open portal. We protect our technology quite heavily, having about 100 patents. And we are based here in Tampere, as I think Jari mentioned. And our second biggest site is in Grenoble, France, and then we have sales offices around the world. And by today, we have about a couple hundred partners, and you can also see already in a public space about 300 products in our website where we have a partner catalogs. So we are really on a mission to make what we call IoT mastery made affordable. So it's really to focus on these infinitely scalable networks for IoT at the cost point that it can really reach new markets. And we are the main contributor of this new non-cellular 5G standard that we also discuss more today. So the network equipment providers and mobile operators have been focusing on bringing this cellular way of doing into IoT for quite some time. And we can recognize Narrowband IoT, LTE-M as a technologies today. They are great technologies, but they really don't do for complete IoT space. So there are black spots, there are service availability challenges, and especially the affordability is an issue. And the cellular way of doing is that they try to densify the base stations to be able to build better and better coverage. What we did by software, or with what we have done by software, is that we have gone to the extreme possible. So by software, that infrastructure piece is in every and each of the device. So every device is an access point. Every device is actually kind of a base station. And that also solves the problem of coverage. So there's no black spots and this kind of a device autonomy that we will discuss as well. And it's also a lot more lower power solution. As you probably know that output power is square to the distance. So if you can arrange a mesh type of a network which can do multi-hopping, the overall energy is a fraction compared to star topology. And here is a kind of a simple comparison that on the left-hand side you can see traditional mesh networks which were born in a domestic environments like smart homes, and they are quite okay if you have 10 to 20 nodes. But what they lack is the scale. They are typically running on single frequency. They start to collide to each other when you scale them up, and the deployment is laborsome because you need to identify the places for routers and so forth. And then the cellular way of working, as I already a little bit touched, is about getting long range, and that's what Narrowband IoT was or is, and that's what LoRa is about, and that's what Sigfox is also about. Challenge with that is that it's difficult to arrange full coverage in buildings, reliable coverage. Another maybe more difficult thing with those is that they are typically based on subscription models. So if you have a light switch and smart light bulb, they don't expect to pay monthly fees for that operation. And the world is full of those use cases. So the decentralized approach on the right-hand side is built on different kind of a philosophy. Here the devices by themselves and in collaboration with their neighbors, they are doing the formation of the network. So they don't need any central function for it. So you can shuffle sensors, millions, to one place, and they come up with the optimized network topology for that situation and takes care of the environment at the given point of time. So they, for example, agree between kind of the, between the two devices per link, they can agree things like what's the exact channel that we are using right now, what's the time slot that we are operating, what's the output power needed to reach only you, because you can reuse the frequency nearby again if you don't disturb the whole area, and then how you also build the routing towards the closest gateway to takeaway points. So that's the philosophy of this network, and then you have these gateway points, which can be actually cellular, so it's agnostic. It can be cellular, Wi-Fi, or fiber. So this is kind of a new layer in the whole wireless networking scheme. And important thing is that now, along with this standardization, and thanks to our very clever people, one of them is here in the audience, who took this standardization through ETSI in the DECT group. With that work, this standard also inherited the 1.9 gigahertz global frequency band for this use. So that's a huge value that is missing from any other wireless standard. This is a slide directly from ETSI, and it's greatly summarized the objectives. So the aim is that this type of network should be able to be deployed by anyone, operated by anybody, or actually doesn't require operation. They are maintenance free because they are fully autonomous, and they could be set up and used anywhere in the world. And they need to be simple and autonomous so that all these objectives are met. An important thing that now when it's having global spectrum or frequency, there is a coexistence and sharing mechanism so that they can build that kind of a very high spectrum efficient operation among the devices. It's also targeted for a number of applications, so agnostic from that standpoint. And it's the first 5G standard that fulfills the two bottom corners simultaneously. So when you see 5G advertisement and 5G product, they are almost solely focusing on this enhanced mobile broadband peak in the triangle. So high bandwidth applications. This standard is focusing on massive scale and affordable, but also ultra reliable low latency operation. And that combination was missing also from the market before. How we then as a Wirepas address this? So we used to, the kind of the university research was focusing much on the kind of the protocol part itself, and that is still the key, and we develop it further as we speak. But to be able to make a good adoption in the market, we have built a much more richer technology suite. So it consists of things like you don't need to manage the network, but you would like to monitor it. So there are monitoring functions. There are obviously security, provisioning. Provisioning is super important in this type of network where you can have millions of nodes in industrial kind of a use. If you need to kind of use labor and time for provisioning, the business case doesn't fly. So there's automated provisioning schemes, remote updates, over-the-air updates. We also offer, which is not in the standard, positioning out of the network. So we can collect the measurements between the nodes in terms of signal strengths and so forth, and they can figure out the relative positions. And giving anchor positions to few of the nodes, they can calculate the rest. So we also sell those services, that how you get location also out of these networks. Gateway software which are open in a GitHub, and also we have an open GitHub assets for cloud connectors and so forth. So with this overall offering, the lead times of development have been able to cut to a half in the past couple of years. So this is super important for our business as well, to be able to grow faster. Now I'm in trouble. So This is to give you a little bit of flavor that how this is different from cellular. So here you can see that there is a OSI model layers on the left, and then you have device level, gateway level, and the backend or cloud. And in traditional kind of a cellular way, the end radio part, it's actually covering the layer 1, layer 2, because it's up to the kind of a medium access. And the rest is then in the actual network side, base stations and so forth. In our case, the device level is actually including good part of that. So that's the mechanism to make autonomous networks, that the routing capability and these like device management aspects are in the device. And this builds up the autonomy. And what is quite remarkable as well is that the code base, the memory footprint, by doing this, is still fraction of the cellular footprint that is focusing only on the medium access. And now you can understand the disruption in a cost model. So there is no operator involved in the mix. And this is then kind of illustrated here in another etsy slide, which tells what I just did. So on the OpEx part, there is no data subscriptions, there's no maintenance operation fees, and then on the kind of a hardware side or CapEx side, the radios can be more simpler because they are single band radios, not complex cellular quad band roaming type of devices. Also, the certification is much more simpler. You don't need to go through all the operators around the world. You only need to make 2 devices to talk to each other, and actually it scales for millions anywhere in the world. And the deployment is rather easy because you don't need to do much of a planning. There are few IoT networks and IoT, let's say, technologies who quite carelessly claim that they are 5G. We have heard even LoRa in some places saying that we are the 5G of IoT. Well, here it's not our say. This was a pretty comprehensive, long process in ITU to get it as a part of IMT 2020. And this is really ITUR say that this is a 5G standard. So we are really proud of that. It's de jure standard that has gone through all the processes, independent evaluation group simulations and results, and they are all green. So maybe more interesting where this is going to be used. So we have few verticals that we are focusing ourselves a bit, maybe more on some than the others, but we are open for anybody to license. So obviously we don't restrict the use. Smart tracking is something that is maybe most blue ocean. So we are solving things that were not able to be done before. And it probably becomes the biggest market of all. And actually it has a potential to become really big market. So let's take an example. So here we have the world's biggest shipping company. And few challenges. One, for example, is that the biggest vessels, they can take 20,000 containers on board. And there's no other radio than this type of a radio that can connect in that type of environment. If you think of cellular, and if you think of 20,000 metallic containers side by side, it's a nightmare. There's a multi-path kind of a fading problems, reflections, and so forth. But when you have a decentralized mesh, one node needs to only get access to one another node. And we did prove that it works. Then that's only in the vessel. Then the other thing is to get it connected throughout the whole supply chain. So there can be, the seaway operation, but also railway, airway, the last mile delivery, and so forth. So you can organize that by putting gateways in few places along those supply chains, and they are staying connected because this supports mobility. And if you don't have the connection, you can still collect the data and upload later when you are connected. But that's just the beginning. With this type of architecture where every node is an access point, when you connect a container, basically you create coverage inside to the container with almost endless scale and density. Again, we can put 1500 radios in a cube meter without collision. That's what we have been able to demonstrate. So connecting containers actually opens the next layer coverage, which is the shipments and items inside the container. And you can imagine what can be the kind of a total volume of that. So these projects takes time for sure, and this also involves standardization. And we are very privileged to work with Maersk, as together we were able to also get it as a part of the Digital Container Shipping Association standard. So we are much looking forward to get into stage where this is launched, and also all the major shipping companies are following. Another example, Prologis is, I think by far, the biggest logistic warehouse owner in the world. About 100 million square meters of warehouses, with 5,000 of them. And they are looking for number of things, as you can imagine. So one need is obviously the buildings themselves. So understanding the pump room operation or condition monitoring and so forth. Then lighting is obvious big thing. By the way, they are one of the biggest solar suppliers in producers in US because of the enormous size of roofs. So lighting is a key, but as they are in logistic, they are also keen to combine the things that if you have a lighting with this type of technology, they actually naturally behave as anchor points, all of them, for asset tracking in those buildings. You don't need the lighting, but it's just kind of comes for free. Actually, we are the only asset tracking technology provider that enables battery operated anchors, and that's a huge saving in installation because you don't need to do wiring. And then they can build these services, goods in, goods out, for the tenants that are having the buildings. Again, this has already been started in terms of deployments, but this whole list is not ready. But it's a great plan. Then part of the asset tracking is the pallets, and really the area where pallets are first coming into the picture is kind of a fresh food supply chain. And there the objective is to put better visibility, transparency of that supply chain. And by doing that, the main goal is actually getting the fruits earlier to the shop. So if they can extend a few days or even a week, it's a great win for the whole kind of waste of fruits. But what makes this challenging from the connectivity standpoint is that as these pallets are reusable, and you pile them in the service centers, you may have 100,000 of them in a small place. So there's no other wireless technology that can have continuous connection without collisions in that type of a setup. We have actually several partners that we are hoping to be able to publish quite soon, and most of them are focusing on fresh food problem first. Then among the public ones, Orange Business Services, they are really taking this indoor positioning and asset tracking part of the offering into their portfolio. So what they are doing is that they are kind of a system integrator, targeting for, it can be warehouses, but it can be also offices or factories, and they are then sourcing OEMs from our open ecosystem for the tags, and then they deploy and obviously operate. Again, here the thing is that the affordability. So when you go go to affordability level where you don't need to wire the infrastructure, it's a big win. And now all this come together. So we are today working in kind of all these steps in the overall end-to-end supply chain as a kind of islands. But as we speak, we are building a readiness to connect the islands. And what we call them is context-aware capability of those radios or nodes. So a DAC need to know what is expected from him. Is it inventory on the spot of pallets, or is it sensor reading, or is it positioning, or is it something that now you can relax, you just go and save power as much as possible, you are not asked to do that frequently. It's a collaboration between the application and the protocol itself. Then let's have a look on other vertical, which is the smart building space. And here I have an example of Clevertronics, which is a great partner of ours from Australia. And they have taken this emergency lighting. So for example, here you can see the green signs on top of every door. They are also sometimes about pathway kind of lighting in an emergency situation. So you can imagine it's actually a surprisingly big market. And it's regulated market in the sense that in some countries you need to check them twice a year. And that's pretty expensive. Now when you have wireless connection, you can check the battery levels, for example, remotely and monitor them any minute. And thanks to this architecture, the deployment is rather easy. The installer doesn't need to care anything about connectivity. He just power them on and put them in place, and the network forms automatically and start to rock. And they are really successful. This example is the Kudos Bank Arena in Sydney, a new big arena where 2,500 emergency lighting points were connected, and they are in great number of other sites. I think they have installed more than 600 sites already with our technology. Fagerhult is the third biggest lighting company in Europe, and obviously they do lighting and light control. But where they are nicely specialized is that they can also add sensors to build occupancy information, so occupancy analytics. And again, if you have connectivity technology that you don't need to care about configurations, just install them and start to get stream of data, then you can start to build these heat maps, which is quite nice, for example, in the shopping malls, or today even in the offices or hotels like this, that you can guide the cleaning processes and understand the space utilization and so forth. And Fagerhult is also in partnership with Sony. So Sony Nimway solution is doing a little bit similar. They are more focusing on office buildings, I think. And then many of you know, there's a Finnish company, Haltian, with the empathic building concept, which has a lot of similarities. So this is growing area, and we are really excited now engaging with the leading building management system companies as well. This, I'm pretty sure if you are from Finland that you have crossed. So this is the Postis delivery box service, or kind of a smart locker. And what we enable here is that the locks themselves, they are completely wireless. So there's no power, no communication wires, because it's so low power. And you can imagine how easy these installments are then to deploy versus that you need to wire them up. And well, I guess you know how it works. So you get the SMS for the PIN and the lock number, and you go and take your order from the box. Then let's move to the factory side. Sulzer is the biggest pump maker in the world, and they have partnered with our local partner here in Tampere called Trion. So they are making this type of industrial node which is measuring the vibrations, temperature, humidity, to be able to monitor the pump operation and predict the failures. And Schaeffler, which is the biggest ball bearing company, has the same concept, but maybe a little bit more broader, because anything that rotates or moves in a factory requires ball bearing. So again, the market opportunity is huge. And not only they are looking the monitoring aspect, because when they are a ball bearing supplier, they also understand other care abouts like lubrication. So lubricators are also connected. Because the reason for failing ball bearing is quite often either too much or too little of lubrication. And these are great examples that, if every factory is getting these things 10% better, it starts to have a huge impact and no downtime. And I would say the biggest impact we are making in this whole mix is that they used to connect 5% of the motors, the most important ones. But now when the affordability is so good, it's no brainer to connect just all. This one I really like personally because it's kind of a good innovation. So it's a hard hat in construction. Wake Up made an update to the kind of adjustment knot in the back of the helmet and then replace it with electronics. And it has Wirepas connectivity, and you can see in the back there is kind of an anchor point. So when the building grows in a construction and there's no infrastructure, you can actually easily make the minimum infrastructure to enable location services in the construction site. So you can have people in, people out counting. You know where they are. You have a fault detection. 3M, the helmet maker, likes it a lot because every time it falls, they should replace the helmet. And then they extend it to tools and so forth. So again, construction sites are getting connected. Bouygues, the big French construction company, is also using our technology similar way. And then obvious place where these networks are pretty powerful is underground. So Coulon is our Australian partner in mines, and they are doing lighting, but also positioning, and actually they have teamed up with the Wake Up, the cap maker, and that's a great example. Our ecosystem partners are finding each other and using each other's technologies to make a better offering. And my last example, or two examples coming from smart metering side. Again, if you are from Finland, there is a certain chance that your home is having Wirepas connectivity already, because we are market leader in Nordic. About 3 million smart metering points connected. And this example is pretty amazing. So it's a Greater Oslo, where almost 1 million meters are connected with this technology in one single mesh. So it's probably 1,000 times bigger than the next biggest mesh, non-Wirepas mesh in the world. And we used to say that there was no base station needed, no repeater, no kind of antennas, external antennas, just the meters. So it makes the deployment super easy. And 1 out of 300 in average is having cellular backhaul. So only those need to be in places where the good cellular coverage is guaranteed. So now we can say that there is almost 1 million base stations in Greater Oslo to make it other way around. And actually that's something that is going to be utilized in India. And this is one of our biggest opportunity right now. We are having really, really big success in the early stage of India deployments. India, the biggest, I would say, rollout in the next 5 years. So they target 250 million metering points. It doesn't happen in this time, I'm pretty sure, but it seems to be happening. It's really in a good way now. And here all these qualities are even more important: the reliability, affordability, and then our business model is excellent here because it's very difficult to build full AMI solution, advanced metering infrastructure solution, in developed country and export it to India. The cost doesn't match. What we do is that we license our software to enable the local ecosystem to create those. And that also supports the Make in India initiative that India is having. So here we have a very, very high hopes to make a good impact. A bit on that market size, and the ones who are in an IoT probably have seen that it's damn difficult to know and quantify what are the opportunity sizes. But I think Ericsson has done pretty good job after the initial prediction, which went quite wrong 10 years ago, or maybe 14 years ago. So this is from the latest mobility report, where they are interestingly separating cellular use for IoT for the kind of a enhanced mobile broadband, so the high bandwidth applications, and then the MMTC applications. And as you can see, it's a very nice growth for this part, but it's impressive growth for the MMTC. So they predict that these massive machine type of communication applications are passing the rest already in a few years. And we as a Wirepas, we obviously want to take that corner. So we now have we have now contributed to the standard that is proven to be superior in that space. And we have the first products for it. But we are not even, that's not even enough for us, because we have two main product kind of branches, if you like. It's the same software, it's the same concept, but what we use for this corner in this model itself is what we called private 5G. And that is using low end of cellular chipsets in the beginning. And we are partnering with the Nordic Semiconductor as we speak, and bring it to market later this year. But we already have products, what we call Wirepas Massive, which is then running on Bluetooth chips. And you can imagine Bluetooth as a 4 to 5 billion annual volume commodity radio is the cheapest possible radio. So it's a sub-dollar in good volume. And that is really where we believe even bigger volume than what Ericsson was saying, the cellular scope. And for those reasons, we see that at least 1 billion TAM in next 5 years is the market for us. And if we put this into perspective of other standards, so in this chart we put cost on the y-axis and IoT-ness, if you like, on the x-axis. So you can see that the cellular technologies are more on the bottom for obvious reasons, because the hardware is more expensive. They are pretty complex radios. They have a complex radio front end because of the frequency plans and so forth. Plus they have a subscription fee. So that limit cellular use in massive scale. And then we have these Bluetooth Zigbee type of meshes which were born in the domestic. They suffer from very, very low bandwidth and ability to scale. So what we did was that with Wirepas Massive, we took this low-cost commodity radios, and with our software, we move it to the place where scale density coverage is in place. And now with this 5G standard, we do the same, but we take the technologies on the physical layer from here and move it here for more affordable play. And now this space is very nice to operate for this huge market. Okay, my last slide. So I hope you now know more about non-cellular 5G, Tech 2020 NR, and about Wirepas. And if you want to join into this nicely growing ecosystem, whether you are in a standardization, whether you are in the semiconductor industry, whether you are making devices, or if you are a solution provider or system integrator, or if you want to join Wirepas, we have nice jobs available, please contact. We are happy to take more on board, and with that, I open for questions.